Welcome to the GearVR Framework Tutorial Lesson 3 on Events and Picking. Event handling uses the concept of event receivers. Event receivers implement the iEvent receiver interface, and a receiver can contain a list of listeners, and it'll dispatch to the handlers in these listeners based on what the event class is. So all event listeners implement the iEvent listener interface and listen for a specific class of event and implement a handler for that event. Events can be used for input devices like your touchpad or mouse or the game controller, and they can be used for control flow too, like the on init and on step events that we looked at in lesson 2. And then picking and collisions, in this lesson, we're going to learn how events are used there. And the asset loader also will generate events. So application events use the iScript events interface. And this class of event, you implement on init and on step. So GVR main is an example of a class that implements this interface. You implemented on init last lesson, and then you also did a stub for on step. Now, GVR scene object is also an iScript events listener, so it can receive on init and on step events. It gets them from the scene because the scene also implements iScript events, and it is responsible for dispatching them to all of the scene objects that it owns. In addition to having Java on init and on step overrides, you can also attach scripts to the activity or the main, or through the GVR script behavior component, you can attach them to scene objects too. And this allows your scene objects to have scripts written in JavaScript or Lua, and these can also handle the events for the application. Here's an example of the application startup, and these are the event handlers that we wrote in lesson 2 for activity to handle creation and touch. Colliders are components that allow you to collide with other objects or with the picker, which generates a ray from the camera. The collider component gives you a simplified collision mesh. It could either be a bounding box, like the bounds of your mesh, a sphere, a bounding sphere, or you could actually use a mesh collider that will collide against all of the triangles in your mesh. This is slower, but a lot more precise than the sphere or bounding box collider. But for a lot of applications, the sphere colliders and the box colliders work just fine. Colliders are used for picking and for cursors. Picking is collision with array. We'll give an example in a little bit. And cursor is collision with a cursor object. So you can, in GearVRF, have cursor objects that move around in the scene and collide to allow you to grasp. Say you have a leap motion controller with cursors on your fingertips. You can grasp objects in the scene. So collisions can get quite complicated. There are two types of colliders supported right now, and we may support more in the future: the sphere collider and the mesh collider. And the mesh collider can either collide with the mesh, the whole thing, or the mesh's bounding box. So to attach a collider, you make a collider component and then you attach it to the scene object. So in lesson 2, we made a scene object that represented a balloon that was transparent. Here's the code from lesson 2. Now what we're going to do is attach a sphere collider to that. Now note that with sphere colliders, even though the object is a sphere, its bounding box is what the collider is computed from, the sphere. So if you let it automatically compute from your mesh, it'll compute from the bounding box, which is actually a little bit bigger than the sphere mesh would be. So here we're going to explicitly set the radius to 1 because that's the radius of a GearVR sphere by default. And let's do that now in code. So we'll bring up Android Studio and we'll add that code in. There we go, the sphere collider. Now note we have to do Alt-Enter inside Android Studio because it doesn't know about the sphere collider yet. Picking is the process of calculating where a ray hits each collider and then sorting based on distance from the ray origin. Now, in this example, and usually, the ray will originate at the camera and follow the camera orientation, so you'll pick what the viewer sees. The hit point is going to be in the local coordinates of the collider. So if you're using a sphere collider or a box collider, it won't be a point on the mesh. It'll be a point on the collider, and it'll be in the coordinates of the mesh. So in this example, the picture shows a sphere collider on the dog, and the hit point is on the sphere, not on the dog. The GearVR picker is the component that does the picking, and you can attach this component to any scene object, and then it'll compute the picking ray based on the scene object's transform. So the origin of the ray will be the position of the scene object, and the direction will be the forward direction of the scene object. If you attach it to the camera, then that's the forward direction of the camera, which is where the viewer looks. And these rays are in camera coordinates. They're not in world coordinates. We generate picking events at each frame. You're guaranteed to at least get an on-pick or an on-no-pick event. The on-pick gives you the sorted list of all of the objects that were picked, the ones closest to the camera first, or closest to the ray origin. On-no-pick indicates the ray didn't penetrate anything. And for each collision, for each collider that you have that the ray is colliding with, you get on enter as soon as the ray enters the collider. It'll continue to give you on inside events as long as the ray is inside that collider. And then when it exits, just as it exits, it gives you an on exit event. And you'll get these events for every collider. So if the ray penetrates more than one, then you could get more than one of these events. Here's a picking event handler example. This example is going to set the color to pink when the object is picked by actually changing the material diffuse color, and it'll set it to red when it's not. And here you see the pick handler is deriving from iPick events. This is the class of events for picking, and you have to override all of the event handlers even if you only use one or two of them. In this case, we don't care about the on enter or on exit for each individual object picked. We only want to know what's the one closest to the camera, and then we're going to remember that one, and we're going to set its color. And then when nothing is picked, we're going to take whatever that object was that we picked and put its color back so that it's not picked anymore. And to listen to pick events, you would have to implement the pick handler and put it into an object and then attach it as a listener to the scene's event receiver. So here we get the event receiver that's associated with the scene that listens to all the events and dispatches them to the scene's listeners. And then we say, make our pick handler one of those listeners, so that when you get events from the scene that are of the class iPick events, you'll come to this handler. And finally, we have to listen for the application touch events, because what we want to do is when we pick something by touching it, in other words, if you're looking at something and then you touch the touchpad, what it'll do is it'll set the diffuse color to blue. So I've opened up Android Studio now, and I'm going to show you how to add the pick handler so that we can implement picking for our Lesson 2 tutorial, which will become Lesson 3. So I've added the pick handler, and now we need to put the variable in for it, the declaration, and we'll put that right up here. And now we enter Alt-Enter, and it'll find that for us. Another Alt-Enter, and it'll find that one, and then it's happy. So now it has the pick handler, but we haven't attached it to anything. So what we need to do is put it into the scene, add a picker, and then attach the listener. So we'll do that right here. We'll make a new picker, and then make a new pick handler, attach the pick handler as a listener to the scene's event receiver. We haven't actually implemented on touch yet, so let's do that now. We will implement on touch by taking the stub out and putting in an implementation that will look at the picked object, if there is one, and if the ray is inside anything. And then if you click on the mouse or the touchpad or you hit the screen, any touch event, it will change the diffuse color to blue. So that's what we're going to do there. And this is our implementation. Now we should build it and test it. We've built our application, so now we can see what does it look like on the phone. So I'm going to drag the little phone window over here and show you if it comes. Okay. And as I move, you can see that it picks. And then if I select while the ray is in there, it'll change the object to blue. And then it can do it over again. So that's what we've done. We've implemented picking on a single balloon. And now in the next lesson, we're going to do more balloons so that we can actually make a game and have some fun. So I hope you enjoyed lesson 3, and we look forward to seeing you in lesson 4.